constrained by their capacity and what they can deliver for you. So there are many, many challenges, and one of the things we do need to see is how do we actually get more substantial, larger scale storage options developed that can deliver in short periods of discharge the kind of power we need. And that's some of the great challenges that the storage industry is trying to address today. So then I think we can say that, we can sort of put a reality check on where we are and say that fundamentally, in terms of scale, we've come a long way, and you can see what's happened to pumped hydro. It's come up significantly, and obviously compressed air as well. But we still have a long way to go on the smaller end of the spectrum and the creep of different types of storage solutions. According to a recent Goldman Sachs report, the best lead-acid batteries cost $150 a kilowatt hour, and the best lithium-ion batteries cost $500 to $1,200 a kilowatt hour. And that just gives you a sense of how expensive storage still remains. And I would say that's probably the fundamental issue that the storage industry is having to address is, can we get the costs down to a level where it's really economic to store? So again, I think it's a balance. There's opportunity, and you can see the opportunity, but there are also very substantial challenges. So just turning to solar, so solar PV is growing stronger now, and there's a lot more grid-tied component, and that's the blue and red portion. So you can see we're growing very substantially. This is 1.2 gigawatts by 2009, and the utility scale element is growing fast as well. Now, Navigant's forecasts that distributed PV could even increase by more than 60% in the next 10 years. So there's plenty more growth available. And the venture capital industry is investing about $1.4 billion. This is 2009 numbers versus the total of $4 billion. And of course, the American Recovery Act has also provided solar provisions to stimulate solar demand in the form of loan guarantees, treasury grants, and investment tax credits. So all these factors are going to contribute to the continued growth of solar over the next few years. And of course, for those that wonder if renewables is material, these are the sorts of revenues that you can expect by 2020 in terms of renewable generation scale. So this is going to require quite a bit of investment, but also there will be some limitations, particularly as the grid starts to absorb very substantial volumes of renewables, and a lot of need to integrate different forms of energy in order to optimize the grid capacity. So very interesting opportunities. So, I talked about large-scale energy storage. From a solar perspective, large-scale energy storage is a significant value-adding tool, and having a smart or a grid that can respond to that is also very important. We can provide voltage variation, reverse power flow, and deal with power fluctuations, and that will help the optimization of the grid. BP has invested quite a bit in storage technologies. We have a holding in a company called Net Power, which is a Chinese manufacturer of zinc-bromine flow batteries. This technology shows great promise as a low-cost energy storage system, which is very valuable for targeting high-demand markets that are very costly to commercial electricity customers. So there's a lot of opportunity. And to sort of summarize the opportunity, the smart grid is clearly going to be integrated with photovoltaic energy. Sorry, I have a question. Go ahead.
Yeah, quick question. You said it was $100 roughly and $500 for lithium. Does that account for the time of replacement, or just exactly what is the time increment that those technologies are expected to survive? In other words, is that $500 per year or $500 per decade? How, most people talk about storage as if it's a one-time expense, when in fact it is something that's going to have to be replaced periodically. And I'm curious what that periodicity is in these cost estimations.
Yeah, I can't answer the specifics around the sort of lifetime of batteries. There's a great variation in that. But I think, for the period of time that those batteries are operating, this is a sort of an average cost per kilowatt hour produced for the sort of lifetime of a battery. Obviously, as I said, there's great variation in terms of the lifetime duration in years. If there are probably better experts on this.
So, Department of Energy has come up with some targets to answer your question called Freedom Car. You may have heard of that, and the target is a 15-year life on a battery. When you talk about numbers, $500 per kilowatt hour is pretty high. It's about a factor of 3 too high. Mm-hmm. But the cost for a battery that lasts 15 years, that delivers the kind of power, this is not grid. I'm talking about just, say, an automobile, small, something like $3,500 for a battery that's got a 15-year lifetime. That's a target. Where we are today is at about $12,000 to $20,000. If you estimate based on whatever cells you want to estimate on, something more like $15,000 to $20,000 for a battery that will have that kind of performance, right? So, just to give you a sense, right? But the numbers that he's giving are they're factors of 3 to 5 too expensive today to what we'd like to see in the next, say, 10 years. I'll talk a little bit about this.
Please go ahead.
Yes, Tom Bartley. I'm an independent consultant. Just an example of one installation. I think it's somewhere Central California, Bakersfield or somewhere. There is an installation of 8 megawatts for 4 hours, 32 megawatt hours, at a cost of about $53 million based upon A123 lithium-ion batteries. So that is one installation that's online today as a pilot project.
Yeah, so I think people are really starting to experiment. Yeah. But I think we're far, far away from the point at which this is scaled or scalable and economic. So I think it's absolutely critical we continue to invest in these pilots and push the technology to its limit. But we're not there yet, and I think we need a very different stimulation in terms of investment to get to the point where this is going to become part of the standard way of managing energy. Another question.
Well, one quick follow-up on this lithium system, the $53 million. What's the expected life duration of that facility for Intel replacement?
That's always a question of how the batteries are used. Do you want to specify life in terms of hours, days, weeks, or in terms of megawatt hours or kilowatt hours processed? For the experimental installations that have been put out there so far for grid projects, the batteries show very little deterioration, and even going to an old technology, lead acid, for one project I'm familiar with, after 10 years they start examining the cells and it looks like they would go for another 5 to 10 years. So in grid applications where the batteries are not hit nearly as hard as they are hit as hard as they are in transportation applications, 5 to 15-year lifetime is probably already expected.
Thank you.
So in terms of the business opportunities around this for the integration of PV with the smart grid, there are really three areas that we've identified. The distributed generation PV power plants, where you can aggregate distributed PV systems across areas or regions into a reliable and predictable energy source. It sort of starts to look like a very rateable power plant that's, say, like a coal plant or a gas plant. There's smart capacity firming, where we could meet end-use energy demand by coordinating the on-site PV and energy storage, a bit like the pilot we just discussed, with demand response to match the particular demand characteristics, and then coordinate end-use demand to utility requirements. And then the third area is grid optimization, where we could, with coordinated control of PV inverters, which convert the DC current we produce in the PV system to AC, we can regulate voltages and provide utilities the ability to trip photovoltaic off in an active mode so that we can stop and start to match demand. So those are three areas where we're focusing on the business opportunities to integrate. So in terms of in summary, in terms of what do we need to do to drive this change, it's our view is it needs to be a coordinated effort on the part of all stakeholders. And so I think this conference actually is a great catalyst for this kind of thinking. The utilities, they are going to invest to improve customer service. They're going to address the renewable portfolio standards that are the requirements for them over the next 5 to 10 years. And they're going to seek to reduce energy costs. So they play that role. Customers need to control demand for energy usage and need to be incentivized to use their energy in different ways during the time of day and to better match supply and create energy efficiency opportunities. Regulators need to revamp the grid regulations to address and enable smart grids to be applied. And of course, investors, which is the point I made earlier, we need more money to develop energy storage, utility-controlled inverters, for example, and other key smart grid components if we're going to see the opportunity that we've identified become reality. So that's all I had.